Have you ever wondered how language is physically stored in the mind? What if it's an environmental signal your brain instantly, physically reacts to? Take an Arabic-English bilingual walking through a modern city. In a single afternoon, they navigate between Arabic and Western spaces, constantly shifting how they communicate. The strange thing is how seamless this is. How does the mind know exactly when to turn on the right language without requiring you to consciously think about it? To find the answer, researchers looked at the environmental pieces of identity surrounding us, like the script on a sign or the culture of a person, to see if these act as the brain's internal switches. To understand exactly how these environmental switches work, researchers Esti Blanco-Elorita and Lena Pilkington set up an experiment in 2015. They placed Arabic-English bilinguals inside an MEG scanner. This highly sensitive device records magnetic fields in the brain, tracking neural activity millisecond by millisecond. By watching the mind in such extreme slow motion, the researchers could literally record a language choice forming before the subject even opened their mouth to speak. Previous experiments tested language switching by showing subjects different colors, like assigning Arabic to blue and English to red. But because that isn't how we navigate the real world, this study used natural, ecologically valid cues instead. They tested two environmental triggers. First, the script. Participants spoke Arabic for an Arabic numeral and English for a Roman numeral. Second, a social trigger. Participants saw dots alongside distinct avatars, an Arab and a Western man, matching their spoken language to the person. Setting the experiment up this way allowed the researchers to ask a highly specific question. Does the brain treat a written symbol differently than a social reality? This graphic maps the exact reaction to the script cue. At 170 milliseconds, a sharp spike localized in the left visual cortex appears. This tells us the brain processes the written character instantly. It operates as an ingrained reflex, recognizing the rule on autopilot. This chart displays what happens when participants saw an Arab face instead. After a reaction in the right visual cortex, activity moves. At 200 milliseconds, this red line spikes. That's the anterior cingulate cortex, the brain's control center for monitoring conflict and managing attention. The increased activity in the ACC suggests that while reading a symbol is a reflex, engaging with a person's identity requires more analysis. The brain has to use more cognitive resources to process the social context before it can confidently select the right words. To test the absolute strength of these reflexes, the researchers introduced a mismatch task. They reversed the rules. If the subject saw an Arabic numeral, they now answered in English. This creates intense cognitive friction. For a fraction of a second, the visual cue tells the brain to fire off the Arabic response, but the participant has to suppress that instinct and force out the English word instead. This graph maps the neurological fallout. Between 300 and 400 milliseconds, these shaded regions show a massive energy surge in a different part of the brain, the left inferior prefrontal cortex. Its job is to apply top-down control to physically suppress ingrained instincts. It takes an immense amount of neurological effort to stop the brain from speaking Arabic when it sees an Arabic cue. That friction proves exactly how tightly the language is wired into the bilingual mind's core architecture. When we track these millisecond by millisecond responses, we see that language isn't just a list of words we've memorized. It is a physical, neurological architecture that reacts to the world in real time. To the bilingual brain, Arabic is a tangible environment. It is a set of ecological realities, symbols, and social cues that the mind physically organizes itself to navigate. The connection to the visual script is incredibly direct. Simply seeing those characters on a page or a screen is a force strong enough to steer cognitive pathways entirely on autopilot. A language, then, operates as a neurological home that the brain recognizes, respects, and physically transforms to meet.